Good morning, my dear students. Welcome to the discussion on the topic development of surfaces. Under this, we are discussing now development of lateral surface of a truncated square pyramid. The method used for the development of lateral surface of truncated square pyramid is radial line method. This is the fourth solved problem we are discussing under development of surfaces related to the radial line method. Now we will enter into the problem. The given problem is a square pyramid base 40 mm side and axis 60 mm long has its base on the HP with two edges of the base parallel to the VP. It is cut by a section plane perpendicular to the VP and inclined at 45 degrees to the HP and bisecting the axis. Draw its development. Now we will extract the data from the problem. The name of the object is square pyramid. Square pyramid means its base is a square and all corners of the base of a square to be joined to a single point called apex with slant lines, and its lateral surface is having four triangular faces. Here the base side of the square pyramid is 40 mm and axis height is 60 mm. That is, the name of the object is square pyramid and its base side length is 40 mm, axis height is 60 mm. In addition to these details, what are the conditions mentioned in the problem? Here, the square pyramid is resting on its base on HP with two of its base sides, say AD and BC, are parallel to the vertical plane. Then the section plane is making an angle 45 degrees to the HP and perpendicular to the VP, and the section plane is bisecting the axis. Then with this information, we need to draw the development of lateral surface of the truncated square pyramid. The solution procedure for the given problem, that is development of lateral surface of truncated square pyramid, is divided into three steps. Step 1. Draw top view and front view of the square pyramid. Step 2. Draw the section plane line in front view with the given condition and locate the intersection points of the section plane and face edges of the pyramid. Step 3. Draw the development of the lateral surface of a truncated square pyramid. Now we will move towards step 1, that is drawing top view and front view of the square pyramid, followed by step 2 as well as step 3. Now we are in first step solution, that is drawing top view as well as front view of the square pyramid. Under this, first we'll draw top view, then we'll move towards drawing the front view of the square pyramid. Here in the problem it is mentioned that the square pyramid is resting on its base, say A, B, C, D on HP with two of its base sides, say AD as well as BC, are parallel to the vertical plane. Because the square pyramid is resting on its base on HP, we will get true shape of the base of a square pyramid in top view. First we will draw true shape of the base of a square pyramid, that is square in top view, keeping the sides, say AD and BC, are parallel to the XY line. So as a first step under it, draw XY line. After that, draw top view of the base of a square pyramid, that is square, with two of its base sides, say BC as well as AD, are parallel to the XY line. This is BC. Then complete the construction of square. Here the base side length of the square pyramid is 40 mm. Here the length of the BC side is 40 mm. Then complete the construction of the square in top view. Then name the corners of the square, say A, B, C, D. After that, in top view, in addition to the base of a square pyramid, we are able to see the slant lines, say OA, OB, OC, OD. So we need to locate point O in the top view. For that, draw diagonals in the top view of a square pyramid's base. Draw diagonals, say AC, BD, both are intersecting at a point called O. O is the image of the apex in top view, and also it is the image of the axis in top view. Here OA, OB, OC, OD are images of the slant lines of a square pyramid in top view. With this we completed drawing the top view of a square pyramid. Then we'll move towards drawing the front view of a square pyramid when it is resting on its base on HP and axis parallel to VP. For drawing the front view of the square pyramid when it is resting on its base on HP and axis parallel to VP, what we have to do? We have to draw the projectors through the top view points, namely A, B, C, D and O towards the vertical plane. After that, along this projector with a distance of 60 mm from the XY line, locate a point O dash, and O dash is the image of the apex in front view. Here, the distance of the O dash from the XY line along the projector is 60 mm, and this distance is nothing but axis height of the pyramid. After that, locate the intersection points of the projectors as well as XY line in front view and name the points as A dash, B dash, C dash, D dash. Then join O dash and A dash, O dash and C dash, A dash and C dash points. This is the image of the square pyramid in front view. With this, we completed drawing top view as well as front view of the square pyramid when it is resting on its base on HP and axis parallel to VP. Then we'll move towards drawing the section plane line in front view. In step 2, we'll draw the section plane as well as locate the intersection points of the section plane with the face edges of a square pyramid. Here, the section plane is passing through the midpoint of the axis and it is making an angle 45 degrees to the XY line. So, locate the midpoint of the axis. This is the midpoint of the axis. This point is at a distance 30 mm from the apex of a square pyramid in front view. Then draw a section plane line which is making an angle 45 degrees to the HP and passing through the midpoint of the axis. This is the section plane. It is also called cutting plane, which is making an angle 45 degrees to the HP. After that, locate the intersection points of the section plane as well as face edges of the square pyramid. Here, O dash A dash, O dash B dash, O dash C dash, O dash D dash are the face edges of a square pyramid. They are also called slant edges of a square pyramid. Here, 1 dash is the intersection point of section plane as well as slant edge O dash A dash. 2 dash is the intersection point of section plane as well as slant edge O dash B dash. 3 dash is the intersection point of section plane as well as slant edge O dash C dash. and 4 dash is the intersection point of section plane as well as slant edge O dash D dash. With this section plane, we are cutting the square pyramid such that this top portion above the section plane region of the square pyramid is removed. Then the portion of the square pyramid below the section plane is retained, and that is to be used for the development purpose. So dot the portion below the section plane line of the square pyramid in front view. This part P of the square pyramid's portion is to be developed. This part P of the square pyramid portion is called truncated pyramid. Our objective is we need to develop the lateral surface of a truncated square pyramid. For developing the lateral surface of a truncated square pyramid, say part P of the square pyramid, what we need to do? We need to draw an arc with a radius is equal to true length of the slant height of a square pyramid. Here, the true length of the slant height of a square pyramid is 1, whose image in the top view is parallel to the xy line. Here, the image of the slant heights, say O dash A dash image in top view, say OA, it is not parallel to the xy line. And O dash B dash slant height image in the top view, say OB, is not parallel to the xy line. O dash C dash image in the top view, say OC, is not parallel to the xy line. O dash D dash slant height image in the top view, say OD, is not parallel to the xy line. That is, the slant heights image in the top view are not parallel to the xy line. But we need to take the true length of the slant height for developing the lateral surface of a square pyramid. For that, what we need to do? With O as a center, draw a line parallel to the xy line. After that, with O as a center, OD as a radius, draw an arc towards this line. Then name this point as D1. Here, OD1 is the image of the true length of the slant height of a square pyramid. So at D1, draw projector towards the XY line. Then name this point as D1 dash. Join O dash and D1 dash. Here, O dash and D1 dash is the true length of the slant height of a square pyramid. Then draw horizontals through 1 dash, 2 dash, 3 dash, 4 dash towards this true length of the slant height, and name those points on the true length of the slant heights as 1 double prime, 2 double prime, 3 double prime, 4 double prime. Here, O dash D1 dash is the true length of the slant height of a square pyramid, and its image in the top view, say OD1, is parallel to the XY line. Then we'll move towards third step, that is development of lateral surface of a square pyramid. Here, first we'll develop the lateral surface of a square pyramid. Then we'll move towards development of lateral surface of truncated square pyramid. For the development of lateral surface of a square pyramid, what we need to do? We need to locate a point O. Then with true length of the slant height, say O dash D1 dash as a radius, draw an arc. Here, this is the true length of the slant height of a square pyramid, that is O dash D1 dash as a radius. Draw an arc and name this point as A. After that, with base side length as a radius, with the A as a center, draw an arc, then name this point as B. Here, base side length is 40 mm. With B as a center, with 40 mm as a radius, draw an arc. With that, you will get point C on this arc. with C as a center, 40 mm as radius, draw an arc on this arc, then name that point as D. With D as a center, 40 mm as radius, draw an arc on this arc, with that you will get point A. Then join OB, OC, OD, OA. Here AB, BC, CD and DA are the base sides of a square pyramid, and OA, OB, OC, OD and OA are the face edges or slant edges of a square pyramid. This is the development of lateral surface of a square pyramid. Then we'll move towards development of lateral surface of a truncated square pyramid. Here, 1 dash is the intersection point of section plane as well as O dash A dash slant edge. And 2 dash is the intersection point of section plane as well as O dash B dash slant edge. Similarly, 3 dash is the intersection point of section plane as well as O dash C dash slant edge. 4 dash is the intersection point of section plane as well as O dash D dash slant edge. O dash 1 double dash as a radius, O as a center, draw an arc on OA slant edge in the development and name this point as 1. That is, with compass O dash 1 double dash as a radius, with compass O dash 1 double dash as a radius, O as a center, draw an arc on OA slant edge in the development and name this point as 1. Then with the same radius, O as a center, draw an arc on OB slant edge. Name this point as 2. Then O dash 3 double dash as a radius. With compass, O dash 3 double dash as a radius and O as a center, draw an arc on OC slant edge and name this point as 3. Then with the same radius, O as a center, draw an arc on OD slant edge and name this point as 4. Then O dash 1 double dash as a radius, O as a center, draw an arc on OA slant edge and name this point as 1. After that, name these points, say 1, 2, 3, 4 and 1. After that, join 1 to 2, 2 to 3, 3 to 4, 4 to 1, 1 to A to 1 with straight line segments. Draw A to 1 points with straight line segment, 1 to 2 points with straight line segments, 2 to 3, 3 to 4, 4 to 1 and 1 to A also with straight line segments. Then dark base edges of the square pyramid in the development, say AB, BC, CD, DA. Then dark portion of the face edges of a square pyramid in the development, say D to 4, C to 3, B to 2. With this, we completed development of the lateral surface of a truncated square pyramid. Now you will see the pencil usage details. Here, the top view of a square pyramid is with H pencil, and the part P portion of the square pyramid in front view is with H pencil, whereas the projectors and the portion which we removed from the square pyramid in front view is with 3H pencil and dimensioning is with 2H pencil. Whereas in the case of development, the portion which we highlighted, that is the red color lines are with H pencil, whereas remaining lines are with 3H pencil. Now we will see the dimensioning details. Here, the base side length of the square pyramid is 40 mm, axis height is 60 mm, and section plane is bisecting the axis. That is, the section plane is passing through the axis at a distance 30 mm from the apex along the axis. That is, here all these dimensions are in millimeters. This is the required development of the lateral surface of a truncated square pyramid. If you have any queries or doubts, you can write under comment section below this video. I'll clarify them. Visit again for more videos on engineering graphics using the links provided under description of this video. Keep learning and knowledge sharing. Thank you for watching.